Shown here is work assembling of optical network systems using fusion splicing for optical fibers. The optical fibers must be pulled out to the fusion splicer, resulting in extra length. Properly managing this extra length requires extra board space and troublesome manual work. NTT Photonics Laboratories has developed an SF fiber-optic connector to allow optical fibers to be installed efficiently on the boards. The SF connector is much more compact than a conventional connector. In fact, it is less than 1/4 of the area and 1/2 of the thickness. Manufacturing costs can also be reduced to 1/4. The SF connector enables optical fiber splicing on the boards easily. Let's take a look at the structure. It involves a micro hole between the socket and the plug. Notice here that the optical fibers only protrude delta L from the plug ends. When the connection is made, the optical fiber is buckled due to this additional length. This buckling causes the ends of the optical fibers to be pushed tightly together, thereby suppressing optical reflections. Here we see the cross-section of the micro hole. The ends of the optical fibers are matched precisely when they pass through the micro hole, allowing the light to pass through without loss. This is an optical board built using the SF optical connectors to mount optical fibers. There is no surplus length of optical fibers, and they are gathered compactly by the connectors. Installation work for the optical fiber is also simple and can be done in a small amount of time. NTT Photonics Laboratories, continuing to develop new optical connectors such as the SF connector, with the goal of increasing the performance and decreasing the cost of optical network systems.